Welcome to Pastor Victor's Academy. Embark on a journey through the world of engineering mathematics and electrical engineering with our educational tutorials designed specifically for engineering students. Whether you're mastering calculus, solving complex circuit problems, or exploring power systems, Pastor Victor's Academy is your ultimate learning companion. Join us as we break down complex concepts into clear, easy-to-understand lessons, helping you build the foundational knowledge and skills needed to excel in engineering mathematics and electrical engineering courses. Subscribe now to kickstart your learning journey and gain the confidence to tackle engineering challenges head-on. Let's unlock the world of mathematics and electrical engineering together, one lesson at a time.
Good day. Welcome to Pastor Victor's Academy. So in this lesson, I'll be giving a brief introduction to functions. So let's get started immediately. So the first question we want to answer in this lesson is, what are functions? I have two definitions here. The first definition says a function is a mathematical rule that assigns unique output to each valid input. Take note of the keywords. Rule. So that is what a function is, a rule. It assigns a unique output to each valid input. Unique output to each valid input, which means that for every valid input, there is always a unique output. So that is what a function is. Another definition says a function of a variable is a rule that describes how a value of the variable is manipulated to generate the value of the output. So let's take note of the keywords in this definition. Now we have the keyword variable. So we have the input variable, we have the output variable. So we usually assign x to this, and we usually assign that's for the input, and for the output we do assign y. But you can assign any alphabet to it. The word rule comes in again that describes how a value of the variable x is manipulated. So, in other words, a function explains the relationship between variables, how a particular variable is manipulated to get another variable. So, we can express it in the form of an equation where we have y is equals to a function of x. F here is a short form for function. X here is the input variable, which is manipulated. Then y here is the output variable. Let's take an example where we have 2x plus 5, y equal to 2x plus 5. Now, this is a function. So it tells us how x is manipulated to get y. Take, for instance, when x is equal to 1. So what does it mean? Multiply 1 by 2 and add 5, which is equal to what? 7. So that is what a function is. The next question we want to answer. Why is a function? Why is function important rather? Why is function important? As an engineering student, why do you need to know about functions? Now, function is important because it helps us to describe or to model relationship between variables, the variables of a system. Let's assume we have a cylinder. Let's say we already know the height, 2 meters, but we don't know the diameter, d. Meaning that you can assign any value to the diameter. Now, assuming we want to perform an analysis on this, that's differentiation, integration, so that we can study changes or accumulation, what do? We should be able to model the relationship between the volume of this cylinder and the diameter of the cylinder. So a function helps us to describe the relationship existing between the volume of the cylinder and the diameter of the cylinder. So when we're able to express it, then we can now begin to perform our analysis, whether integration, whether differentiation, limits, and the rest. So that's the importance of a function. Now, I want us to note certain things. I want us to note certain things. And the first one is that all functions are equations, but not all equations are functions. All functions are equations. So you are familiar with equations in your secondary school. So when we are talking about functions, understand we are talking about equations. But that doesn't mean all equations are functions. All equations are not functions. So what makes a function differ from an equation? The first one is that a function explicitly defines one variable, that's the output, in terms of another variable, that's the input. So when I'm defining one variable, let's say y, in terms of what? X, we call the equation what? A function. That doesn't mean that a function must always depend on one variable, or the output of a function rather must always be defined in terms of one variable. It could be more than one variable, but one one variable is defined in terms of the other because that's the one we're interested in. We want to understand how other variables are related to that particular one, which is known as the output variable. So that is the first thing. One variable is defined in terms of another. Now, take for instance, you have x squared plus y squared equal to 4. Now, this is not a function because we are just having an equation here saying that when we square this variable and add it to the square of this variable, we'll be having 4. So none is defined in terms of the other. But when we make y subject, that means we have a function because we're actually defining y in terms of x. Now, what else do we need to know about a function? A function assigns exactly one output to each valid input. The word valid indicates that the input may not always be what? Valid. The input may not always be valid. So when we have a valid input, there must be a unique value for the output. So a function assigns exactly one output to each valid input. In other words, you can't have two answers for a particular input. You can't have two answers for a particular input. Take for instance, you have y equal to root 4. This is not a function. It's just an equation. Why? Because root 4 could be minus 2 or plus what? 2. So there are two possibilities. So that makes it not to be a function because we can have two values for the output when we only have one value for the input. But the other way around is a function. What I mean by the other way around, we can have two inputs giving birth to the same output. So that is a function. But when it happens this way, it is not a what? A function. Now, what else do we need to know about a function? A function passes the vertical line test. Now, that is based on this second point which I made, because a function must have a unique value for the output, that's for every valid input. So a function passes the vertical line test. So what's the vertical line test all about? Now, assuming we are to plot a graph, we're having a vertical y and x axis, that's vertical and horizontal axis. Now these are vertical axis, these are horizontal axis. Now let's assume we have a graph like this. Definitely, when you draw a vertical line across this, the line will intersect with this graph on 2 points. Meaning that for this variable of x, sorry, for this value of x rather, we are having two answers, or we're having two values. So for this value of x, we're having two values of y. And that makes it not to be a function. So whatever equation that gave birth to this graph is not regarded as a function. It's not regarded as a function. But assuming we have something like this is a function. Why? Because at every point in the graph, the vertical line intersects only on one what? Point. Draw another line, we have only one intersection. Draw another line, we have only one intersection. So as a result, this is regarded as a function, but this is not, because at almost every point we have two values for what? For y. Okay. Now that takes us to the next thing. That's properties of a function. Properties of a function. The first property I want to talk about is the domain and range of a function. So a function has what we call domain and range. Now let's have A, B, C, D, E, and let's have F, G, H, I. Okay. Now here we'll call this the domain. Here we'll call this the range. So what's the domain? The domain is the set of all possible input values. So all the input values that you can get for a particular function is called the domain. So set of all possible input values. Whereas the range is the set of all possible output values. So then the next property is injectivity. Injectivity is also called one-to-one function. One-to-one function. Now, let's say we have A, B, C, D, E, F, G, H, I. So this function is injective if each output value has an input value assigned to it, but not necessarily all the output values. Now, we can have A assigned to E, B assigned to F, C assigned to G, D assigned to H. But I is left out. There is no input value assigned to it. So in that case, the function that describes this relationship is said to be injective. And the next guy is subjectivity. That's the next property we want to talk about, is subjectivity. Now, in the case of subjectivity, all the output values must have at least one input value that is assigned to it. All the output values must have at least one input value assigned to it. So you can see A is assigned to E, B is assigned to F. Then we have C and D assigned to G. C and D assigned to G. So in this case, this function, the function that describes this relationship, is said to be subjective. Now, the next property combines both the property of injectivity and subjectivity. So when a function is injective and subjective, this function is said to be bijective. Bijective. So that's the property, bijectivity. Now, this means that for each output, there is only one input assigned to it. That means all the output values must have an input value assigned to them. all the output values must have input values assigned to them. Then each output value has a particular input value assigned to it, not two values assigned to one. Now it is one value assigned to one, and all the output values have input values assigned to them, implying that the domain and the range are equal. The domain and the range are equal. That means the values in the domain, possible values in the domain, and possible values in the range are equal, where each output value has a unique input value assigned to it. So that's for the bijectivity property. It's also called one-to-one correspondence. That means one value corresponds to the other. Now, the next property is continuity. What is it about? A function is said to be continuous when the graph of the function has no break or jump. Assuming we are to plot the graph of a function, and in the course of plotting, we'll have a gap here. This gap shows that the function is not continuous because this is a break, this is a jump, meaning that at this particular point, the function is undefined. So when we have such situation, we say that the function is not continuous. Now, to express it mathematically, we have limits of a function of x as x approaches a equal to f of what? A. When this condition holds for all values of x, the function is said to be continuous. Meaning that because x here is a variable, so as we begin to assign values to that variable, then what happens to the function? So let's assume that x becomes a or x approaches a, whichever one. That means automatically f of x should be equal to what? F of what? A. So the limit of this function should be this as x approaches a for a continuous function. The next property I want to talk about is differentiability. Differentiability. A function is said to be differentiable when it has a derivative at every point in its domain. So when there is a derivative for the function at every point in the domain, that means the function is differentiable. Then we have what we call even functions and odd functions. An even function is symmetric about the y-axis. Look at this graph. We have y-axis, x-axis, something like this. Don't mind my diagram. Just trying to sketch. Something like this is an even function. Why? Here, this part is a mirror image of this part. Okay, let's have another one. This is also an even function. Let's have another one. This is also an even function. Why? It is symmetric about the y-axis. It is symmetric about the y-axis. Now, the equation of the even function. Let's write the equation of an even function or mathematical relationship. It says that f of minus x is equal to f of x. What does this mean? That the function of minus 1 is equal to the function of 1. Meaning that whatever y is when x is minus 1 is what y will be when x is what? 1. So that's what this function is talking about, or this expression rather is talking about. That the function of x at minus 1 is equal to the function of x at 1. Now take for instance we have this. Now you can see the value of y here, let's say 2, is the same when we have minus 1 and 1. The same thing applies here. Let's say minus 1, 1. So y has the same value for 2 inputs. So when we have 1, we have, let's say 2. And when we have minus 1, we still have 2. So in that case, it is an even function. It is an even function. Now, the next thing, okay, that's the odd function. It is symmetric about the origin, not the x-axis. because symmetry around about the x-axis shows that it is just an equation and not a function. It is just an equation and not a function because it will fail the vertical line test. But when it is symmetric about the origin, we call it an odd function. Now, take for instance, you have this. Uh, let's say you have this. Here is the origin. So you can see that the shape here is the shape we have here, but they are opposites. While this one is facing up, this one is facing down. So when we have such situation, okay, take for instance, you have a straight line here, you have a straight line here that are exactly the same but opposite to each other. So in that case, we say that the graph is symmetric about the origin. Let's assume we have -1 here and we have 2. I will have -2 here for y-axis rather. So -2 here and we'll have 1. You can see that this is an odd function. Now, mathematically, we can express it this way, that f of negative x is equal to negative f of x. Now, what does this mean? That when x is a negative value, the result we get will be equal to the result we get when x is a positive value and the negative, and we take the negative of the answer. Now, take for instance, x is -1, so f of -1 is what? 2. Now, let's check the other part of the equation. F of 1 is what? -2. So, negative into -2. Negative into f of 1 rather is equal to negative into -2. So you can see that we had -2 here. And we'll have we have 2 here and we'll have 2 here. So we have 2 for this, we have 2 for this. So this is the expression for an odd function, that the function of the negative of the variable, like the input variable, is equal to the negative of the function of the positive of the input variable. Okay, the next guy is, that's the next property is periodicity. Periodicity, it comes from the word periodic. When is a function periodic? A function is periodic when it repeats itself at a particular interval. At a particular interval. Okay. Mathematically, we can say f of x plus t is equal to f of x. So that means whatever x is, after the interval t, we will get the same value. That's what it means. Example includes sine x, cos x. These are periodic functions. After a particular interval, you get the same value. So that means f of 2 plus t is equal to f of what? 2. F of 1 plus t is equal to f of what? 1. So that's what a periodicity is. Then the last thing I want to talk about is boundedness. 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 Now, the first one under that is bounded above. A function is bounded above if f of x is less than or equal to m. So, if f of x is less than or equal to m, the function is bounded above. This means that the function can never exceed the value m. It can only be less than or equal to the value m. So in that case, the function is bounded above. But when the function is not bounded above, we have f of x is less than infinity, meaning that the function keeps increasing without bound or without limits. So we don't know where it will terminate, it just keeps increasing. Then a function is bounded below if f of x is greater than or equal to m. So meaning that the function cannot decrease below m. It can only be equal to m or greater than m. but it cannot go below it. Okay, assuming we use the number line, now we have -2, then -1, 0, 1, 2. Then this tends to infinity, this tends to negative infinity. Now, if my capital M is this, let's call this capital M. That means no matter what the input value is, my function will not exceed 2. That's if the function is bounded above. But if the function is not bounded above, it will keep increasing to infinity. Then for bounded below, I can pick -1 as my small m. That means my function cannot be less than -1. It will only be equal to -1 or greater than -1. But when it is not bounded below, that means f of x is greater than negative infinity. So it keeps decreasing. We don't know the limit. It keeps decreasing. So that's for boundedness. So we've come to the end of today's lesson. Thank you so much for watching. Please like, share, comment, and subscribe. Thank you so much.